Hello, my name is Oliver Maiß, and I am the head of the Research and Development Department here at ECOROLL AG. Today, I want to show you how to properly use single-roller mechanical roller burnishing and explain how they are constructed. Burnishing and deep rolling rollers, also known as roller burnishing tools, can basically be divided into two groups. On one side, we have the mechanical tools, and on the other side, the hydrostatic tools. With mechanical tools, we basically distinguish between single-roller and multi-roller tools. With single-roller mechanical tools, we have just one roller that is in use. And today, we're going to focus a bit more on these. With multi-roller mechanical tools, the rollers are distributed around the circumference. There are many roller burnishing tools that are expanded by a cone and then, so to speak, move into a bore. Single-roller mechanical tools look like this or something similar. Here we have a modern tool with a digital dial gauge. This is the EcoSense type, which also allows rolling forces to be documented. But that's just one example of a tool. Tools can also look completely different. I brought a tool with me to show you how it works. This here is a mechanical single-roller mechanical roller burnishing. This is now an EG5 with a 40M roller. As I said, the tools are always built the same way, just like you see on the slide. We always have a clamping section on one side. That's basically the part where the tool is clamped into the machine. Of course, we can design that however you need it. Here, it's a capto holder, but we can also attach a VDI holder, an HSK holder, a clamping bar, or whatever else you need on the back here. In between or after that comes the so-called main body. The main body is a two-part element. We always have a fixed or stationary part and a spring-loaded part. We can take a look at the back of the tool here. Here we have the main body, so to speak, the fixed part that is connected to the machine tool. And up front we have the roller holder, which is still connected with an elastic intermediate piece and then can flex accordingly. The spring packs are installed here at the top and bottom so that we can allow for a displacement between the fixed and the movable part. Now, if I press my workpiece onto the surface, then I deflect my springs even further. If I keep advancing and it flexes, so to speak, the part moves upward. And by measuring the deflection of the springs, I can determine my specific rolling force. The rolling force itself is measured like here in the picture, for example, it's shown being measured with a digital gauge, and then it can also be saved. And in this way, the rolling force can be documented for each individual process. Or, as we have in this example, we use an analog gauge. This analog gauge basically shows nothing other than the deflection of the spring. And then, based on the deflection and the spring characteristics, you can deduce, so to speak, what force I have at what deflection because applied. The roller burnishing is then installed down here. Right here we have a 40M roller, but we'll see that in a moment as well. Of course, there are also a variety of different rollers that can be installed there. To introduce a few different tool variants, I've brought along a small selection here. On the left side of the picture here we have an EG45 with a 40M roller. This is a rather larger tool which provides high rolling force. It can apply that force and, of course, can process larger components very efficiently. The counterpart to this tool is basically the smallest tool in this little group. That's a so-called EG3T tool. I have my little presenter here just as an example. It's about the same size as this EG3T tool. So it's really suitable for machining in machines with the smallest installation spaces. The other tool I brought with me here is an EG532 AI. The AI stands for external and internal machining. That's why the roller body or roller holder here extends out so far, because I want to be able to move into a bore. But I also want to machine a cylindrical outer surface on the component. And so with this tool, I can basically enable two machining directions directly without having to change the tool. You see, there are many different versions of tools. In reality, there are many, many more. Basically, we always build exactly what you need. The roller holder can be customized, the roller can be customized, and the tool clamping as well. but the structure of this tool is always as I just described it. Now I'd like to explain to you once again how you can change a roller. For this, I've brought a slightly different tool with me. Here, I've also brought an EG5 tool with a clamping bar with a 5mm roller that is mounted on a support roller. We can also see here that there are 3 rollers around the circumference. One of the rollers is the working roller, the other 2 are basically just spare rollers that can be swapped in. And if I now have to replace all 3 rollers, because all 3 are worn out, then I loosen the screw in the middle, pull down my cage. With the 3 rollers, replace the rollers in the cage, put the cage back on, making sure that this groove is properly inserted into the pin at the top, so that the roller is exactly centered on the axis. Then I tighten the screw again, secure everything, and I can continue working. With my processing, just put the tool back in and get started. So it's very simple, and it works just as easily with other rollers, hard ones. The principle is basically always the same. Very easy and quick to handle in your production. With that, I would like to sincerely thank you for your interest in our tools. If you have any questions about using, assembling, or applying these tools, please feel free to contact me or my colleagues at ECOROLL.